Hi all, welcome back to a series of UDS sessions. Today we are going to discuss on the read data by identifier service 0x22 service. So by the name itself it suggests read data by identifier. So we are reading the information by data identifier. As we discussed, this is all UDS service is based on the client server communication. Client will request some data to the server and server send back or response back data to the client. So read data by identifier. I'm reading some data from server. So it's for example, I'm the consumer. I'll go to a fruit shop. I'll ask fruit shopper what type of fruits he have. That is the request I'm sending to him. He's get to know what I'm asking. He'll process and checks, and he responds back to me saying, "Hello, these many fruits I have." This is a response. This is exactly this way communication happens using read data by identifier. So read data identifier service allows the client to request the data record values from the server identified by. So the read data identifier service allows the client to request data record. As we discussed, we want to know something about the vehicle and we want to read some information from the vehicle. So we need to send a request first, then it will respond back. So the request whatever we are sending that may includes about vehicle identification number, uh, we usually call as VIN numbers. That is vehicle identification number. It's different each car to car. This VIN number is unique identification number compared to each cars. It has a different unique identification numbers. So we can read the vehicle identification numbers, uh, unique signal number of a serial number of a vehicle we can say, and we can read the ECU software and hardware versions. This is this is for ECU. So many issues will be there: airbag issue, uh, active and passive systems issues like engine related issues, ABS. So many issues are there. So we are reading ECU software hardware versions. From that we need to send a request and we can get software parameters, versions, and some hardware identification numbers. We can get it. Next, we can read odometer values. So, what is the odometer value? What is the speed? So, what other like what is the fuel? Something. So, those information also we can read from the vehicle using this service 22. And also we can read sensor values, real-time sensor values. Many sensor will be there. Temperature sensor will be there. Pressure sensor, humidity sensor. Many sensor wheel sensors, so brake sensors, light sensors, many sensors will be there. So we will be assigning the different reads to different components. So from that, using this particular service 22, we can read a particular real-time data such as engine temperature, battery voltage, speed, etc. So those values we can read from the service 22. And configuration and coding. So whatever the configuration we have done, whatever the coding related to vehicle we have done will be stored in a particular memory that can be read back. So configuration coding data. These parameters and settings used for ECU operations. Next, we can use some calibration related. We used to call as data, calib ID. So calibration data we can use. So values used for engine and system tuning. So predefined values we can use it. And also with this data we can use that for diagnostic trouble DTC data troubleshoot. So DTC data, snapshot data, we can read it, or snapshot data is nothing but freeze frame or event data related to faults. That DTC part we will be seeing in next upcoming sessions. And we can use security and access levels. So we can request what are the current security status or access mode is enabled, and some manufacturing information like production date or supplied code, etc. Those information also we can read it. The client request message contains one or more 2-byte data identifier values that identify data record. So here mainly suppose one data is data identifier is a data identifier, shortly we can call as DID. So you will be hearing this word who are working in diagnostics field. So DID is a diagnostic identifier. We have many DIDs. One DID for temperature, and one DID for pressure, and one DID for knowing sensor values. So whatever information is there, like sensor values, odometer values, temperature, pressure, brake alignment, what is the transmission type, what is the transmission numbers we have. To get all these, then we have separate DID number will be configured. From that DID number, we can send the request to the server and we can get to know the information. So what we are telling, the client request message contains one or more 2-byte data identifier. So using this service 22 and using followed by this date, I can send a request. And also not only one, if I want to read the temperature, what I can send 22, I'll send did number, I'll send. So it get to know from that did number what we are reading. So one did number will be different did numbers will be there. From that server get to know what exactly I'm wanting. So from that it will send a response back. So one did, if I send, it will send a response to particular did, and continuously two dids. If I want temperature and pressure at the same time in one response, then I can request for two dids. Like that, we can send a request, and we'll see the example in next slide. So upon receiving the read data identifier request, the server shall access the data elements of the record specified by the data identifier parameters. Data records is nothing but the data. I'm asking for the what is the pressure, then the server sending back the pressure value. This Pascal or this Pascal pressure will be there. This is the record data. Record data is nothing but what value we need exactly, and transmit the record data or values in a single read data identifier. So record data what we are asking from server, right? So that will be a single read data identifier message. So if I send request in one message only, it is server should send the data or value, and the positive response containing the associated data required message. So as we know, all communication happens in diagnostics request and response methodology. Like client and server, they are communicating. Client sending the request to a server, and server sending back response to a client. So if I get positive response, then task done. The server send a positive response. It means positive response with data record. It will be send the all data records whatever requested from the client with one positive response. So that is what this identifier service 22 service supports. So if you see how exactly request and response message format will be there, how UDS specification allows. So this is the format. Uh, First, if you want to send a request, then first byte will be a request SID. SID is nothing but 22 number hex 22. It will be in hex format. I need to send a 22 first. The first and second byte will be a data identifier. Data identifier is nothing but the did number. One number will be given for each data. Uh, See data identifier one, I can request it suppose 00 to FF range. So if you want to with this data again other information, if you want to read again next did, you can another did number you can request. That also, that response also it will be given by server. So that same data is like data identifier is comes with the 2 bytes always. It is a standard. It is of 2 bytes. So next I'll send a 22 followed by did, next followed by did to 2 bytes continuously, and that supports 00 to FF. So next will be the data identifier TLM. So these many data identifiers continuously in one request message we can send, but usually in many projects only single data identifier using for one request to get a positive response from the server. So many projects will support most of the time only single DID to request. And next is the positive response message. How the response behavior and message format will be there from server. So from that server, we are sending the response. We are receiving the response here. First byte will be as usual SID, that is 62. So 22 is there. You will get plus 40 always in plus 40 will be added. That is what 62. So whatever service you take, if you last time we discussed 10, right? Service 10 in last lectures. Service 10 in post response first plus 40 will be added. Then it is added with 10 plus 40 50 50 post response. Now we are using 22. 22 plus 40 will be 62. 62. So once 62 will be received, that means is a positive response. Next, followed by data identifier, that same data supports. Then lastly, it will give a particular data record, data for data identifier. See, 62 is a positive response for starting 1 byte, followed by a did, whatever we requested did, then followed by what the information we need, right? We requested information, right? That information appended in after the did. Server will give the uh, data record in next byte. First byte service SID. Next 2 byte is reserved for did. After 2 bytes, from third bytes onwards, the data record, whatever data we need, right? That data we will be receiving it. So this is what we have a standard request and response message formats for service 22. So we'll see one example. So it is just example. Uh, Suppose we have configured one did number is 0x1234. It's 2 bytes. This has 2 bytes. Okay, 2 bytes always standard did size will be 2 bytes. I have configured 1234 is a did number. I have configured 2 bytes did number to read the temperature value from my sensor. So already configured, and that software will be flashed. The moment if I send a request, I need to send a request using the service 22, right? First byte I need to write a service 22. Next followed by 2 bytes of did, that is 1, 2, and 3, 4. This is a request. The moment server detects is 1, 2, 3, 4, it always it has a many information. You already get to know, oh, this 1, 2, 3, 4 it is related to a temperature value from a sensor. So I need to process and send a temperature value to the client. It get to know. So I have a client, I have a receiver. I'm just I want to communicate with the receiver. Then I'll send first request to a server. Request will be 0, 3, 22, 12, and 34. So we already discussed 03 is nothing but standard PCI length. So it ensures how many bytes we are sending. So 22 is the SID, 1, 2, 3, 4 is the did number. So total 3 bytes. That is, it includes 3 bytes. It get to know how many bytes total. Then ECU processes, it get to know 1, 2, 3, 4 is related temperature sensor, particular sensor value. Then it will send a response to us, to the tester. Response will be 62. As we discussed, 62 is a plus 40 added, shows a positive response, followed by 2 bytes same did identifier, and 18. 18 is a data record data. We got some value from the server. It is in hex format. Maybe if you 18 means, I think 27 will be in decimal format. 20. So it means temperature we are reading, it will be in degree Celsius. The moment if you receive 18 is nothing but in decimal 27 degrees Celsius. So it is giving, I asked what is the temperature, server it is giving back us the, hey, it is 27 degrees Celsius now currently. So this is as usual PCI length, 4 bytes overall if you count all these bytes. This is how the communication will happen from between the client and the server using read data identifier service. And we need to see what are the supported negative response codes also, because we are sending a response and we are getting the positive response we discussed. Suppose if data is not processed, something it should send, right? Some information it don't have particular information or something like that. Sorry, it should read that information. So for that, negative response codes will be helpful to get to know what went wrong with the server. So here if you see, I have a list of NRCs like NRC 13, 14, 22, 31, 33. These are the total NRCs supported for the service 22. So NRC 13 is the incorrect message length. The format. So format how is I'll send 22 and 2 bytes did number I'm sending. So instead of 2 bytes, if I send 3 bytes, so if I send 3 bytes, that will be a incorrect message length because request message now we configured like 1 byte of SID and 1 byte of DID. If I send other than DID, if I send any data record itself in request message, which will not support something 18, if I write after did, this is incorrect. So that time it will throw NRC to us. Hey, this is incorrect message length or in invalid format. So how we will receive it? Will receive the response like this 7F and followed by which service we are requested. 22 we have requested, and what is the NRC number here? 13. Correct, right? We have 13 NRC number followed by here 13. 7 of 22 13 is the incorrect message length. Next 14 is response too long. This NRC shall be sent if the total length of the response message exceeds the limit of the underlying transport protocol. We have using some transport protocol CAN, LIN, FlexiRay, MOT or something. It will be defined this much of length it will support for that. If it is too long for the response, then it will send a 14 in the response. 7 of 22 14 like that. Response too long. 22 condition not correct. This NRC shall be sent if the operating condition of the server are not met to perform the required action. Every time if you want to read something information from the server, some few particular information, they need some conditions we need to set. We can call it as a preconditions or entry conditions. To set that, then only it will enable some information to read for the tester. If it is not met, then it will throw 7 of 22 and 22. 22 is a condition not correct. 31 request out of range. This NRC shall be sent if none of the requested identifier values are supported by the device. You are sending this 22 did or some data which is not supported for that service. Then that time it will throw NRC 31. Also, if did itself is not configured, I am sending 1, 2, 3, 4 did number, but it is not configured at all in our project. Then that time also we can expect 31 NRC 31, which is did not supported. 33 is security access denied. In few cases we need a security access. We need to unlock the security for the server. Then only we can go and read the information. And security access most of them when we go for flashing the data or write data by identifier, we are doing right many things. In next slide we'll be discussing that particular service. There we face with many things regarding the security access. But usually some this is for prevent unauthorized person to do some tasks. Okay, for that security access will be there. If you not able to unlock, then it will receive an 33. So by saying so you don't have access, so security access is denied. This is what it will tell. This is that's it for service 22.